So given that 1 is supplementary to 2, and angle 3 is supplementary to angle 4, and 2 is congruent to angle 4, then angle 1 is congruent to angle 3. Well, we already know they're supplementary because they're linear pairs. So we honestly didn't really even need a picture here. But we know that 2 and 4 are equal. And we want to say that 1 and 3 are equal. And it kind of makes sense that 1 and 3 have to be, because 1 and 3 have to add up to 2 and 4, and they are the same, so 1 and 3 have to be the same. But we have to prove that. So let's start off with our givens. 1 is sup to angle 2, and angle 3 is sup to angle 4, and angle 2 is congruent to angle 4. And those are all given. So the only thing I really know is the sups. So let's use the definition of supplementary, or our if-then statement dealing with supplementary. Angle 1 plus angle 2 equals 180. And angle 3 plus angle 4 equals 180. And that would be if supplementary angles, then the sum is 180. Since our given said supplementary, we would use a supplementary rule and not a linear pair rule, even though in the picture they are linear pairs. Now, if I'm going to say that 1 is equal to 3, I have to somehow get them in the same equation. Conveniently, these are both equal to 180. So I can substitute angle 1 plus angle 2 equals angle 3 plus angle 4. And again, I want to say 1 and 3 are the same. Well, I've got this extra stuff. Conveniently, that extra stuff is congruent. So I can subtract it out, and I can say angle 1 equals angle 3 because of subtraction. And I'm finished. So this time I have no givens. I just have to look at the picture. And I want to prove that 180 minus WXV. Right away, I don't like that that's 3 letters. Maybe I will just rename it, and I'll call this angle 1. And WXZ, so this guy, and I'll call that angle 2. You're totally allowed to do that. Just make sure that if you choose to do that, you are clearly labeling it in your picture so I know which angles you're talking about. So I'm thinking that if I want to say something about 180, I probably should say that these angles are supplementary. And if I'm going to say they're supplementary, I really have to work on the fact that they're a linear pair. So I'm going to say angle 1 and angle 2 are a, oops, didn't give myself enough space, right? Linear pair. You can abbreviate that LP if you want. And I would say the reason for that is if angles form a line, then linear pair. Since I know that these angles are a linear pair, then I would say that those angles are sup. Angle 1 and angle 2 are sup. Because if angles form a linear pair, then they are sup. And we know that if angles are sup, then they add up to be 180. So now I can say if sup, then 180. And I'm sure you're all getting very upset and very angry right now because it took 3 steps to say that 2 angles that we know equal 180 are actually 180. And that's just one of those tedious things that you have to do in proofs. You'll learn some shortcuts in the future, but for now you have to write out everything. Anytime you want to use a linear pair, you basically have 3 steps. So now I want to say that 180 minus angle 1 equals angle 2. Well, that's just me using the subtraction property, but before I subtract angle 1 away, I have to use the reflexive property to say that it's equal to itself, because I can only subtract equal things. And I'm finished. So I know that angle 1 and angle 2 form a linear pair. I also know that angle 1 and angle 1 plus angle 3 equals 180. And I want to say that angle 2 is equal to angle 3. Well, let's see what we got. A lot of times you won't be given that 2 angles form a linear pair. But in this case we did, so we'll write it down in our given. We could have also really seen that from the picture. So, using this guy, if angle 1 and angle 2 form a linear pair, then angle 1 and angle 2 are supp. Because if you have a linear pair, then you are supp. And then I have the measure of angle 1 plus the measure of angle 2 equals 180. And that would be because if you have supplementary angles, then you have a linear pair. And my goal is to say that 2 equals 3. So 2 and 3. I've got to somehow make them be equal. Cool. Conveniently, both of those equations have a 180 in them. So I can substitute. And now they're in the same equation. They're almost equal, but I've got that extra stuff. Conveniently, I can take that extra stuff away. But first, I say the reflexive property. And then I can subtract it. Given that angle 4 is equal to angle 7, I want to prove 5 is equal to 6. And again, this is actually very similar to the first one we did. The picture just looks a little different. We'll actually kind of follow almost the exact same process. So, angle 4 is congruent to angle 7. So we see we have some linear pairs. Let's see what the linear pairs are. Angle 4 and angle 5 are a linear pair. And angle 6 and angle 7 are linear pair. Because if you have a linear pair, then, whoops, sorry, that's not right. Let's go next. Because if angles form linear pair, form a line, then they make a linear pair. Then angle 4 and angle 5 are supp. And angle 6 and angle 7 are supp. Because if you have a linear pair, then we have supplementary angles. And now I can say angle 4 plus angle 7 equals 180. And the measure of angle 6, oops, that's 5, sorry, plus the measure of angle 7 equals 180. My goal is to say that 5 and 6 are the same. To do that, they have to be in the same equation. Conveniently, both of those equations equal 180. So I can say angle 4 plus angle 5 equals the measure of angle 6 plus the measure of angle 7. So now I got 5 and 6 in the same equation. I got to get rid of 4 and 7. Conveniently look back at the very beginning. 4 and 7 are equal. So I can say angle 5 is equal to angle 7. Or congruent, or angle 6, sorry. And again, this says congruent. I know that you know that congruence and equal are the same. Ooh, let's catch up our reasons though. Over here, our reasons would be if supp, then your sum is 180. And this guy would just be substitution and subtraction. This one could be done a couple different ways. It could be done using angle addition postulate, or it could be done using linear pairs. It actually doesn't matter. You'll get about the same steps either way. So here, WXZ is equal to VXY. And I want to eventually say that 1 and 3 are the same. So you can use linear pairs or you cannot use linear pairs. I think since everything else in here has been using linear pairs, I'll stick with it. So I'm going to say that angle 1, oh sorry, my givens. Angle WXZ is congruent to angle VX. And then I've got angle 1 and angle VXY are a linear pair. And also angle 3 and angle WXZ are a linear pair. So that might be kind of hard to see. If you're looking at the line this way, it's 1 and VXY. It's y. And if you're looking at the line this way, it's 3 and ZXW. Then we go, and then we go through the tedious process again of saying that angle 1 and angle VXY are supp, and angle 3 and angle WXZ are supp. And then I can say the measure of angle 1 plus the measure of angle VXY equals 180. And then the measure of angle 3 plus the measure of angle WXZ also equals 180. My goal is to say that 1 and 3 are the same. So I will substitute the measure of angle 1 plus the measure of angle VXY equals the measure of angle 3